My name is Jim Hester. I'm a software engineer at RStudio. I'm going to be talking today about the glue package, which is a package used for gluing strings to data. So what does this mean? I'm sure that you've done this in other places, other contexts. So in Excel, you can do this with the concatenate function. You have two pieces of data. You have some sort of string in the middle, and you want to glue them together. You can also do this in Bash. So this is often also called string interpolation. So you have data in a variable, and you want to include that in a command. You use the $ syntax. And in Python and other programming languages, they often have a syntax for this. Python has a few, one of which is the format method for strings, as well as in Python 3.6 and above, this f-string syntax, which is partially where the glue syntax is derived from. So I have always found in R that gluing strings and putting values into string data is actually fairly painful. So the two common ways to do this in base R are with the paste0 function, which has the main drawback that for every time you put a value in, you have to use quotes and then put your variable and then put more quotes and the rest of the string. And if you do this for one or two variables, that's okay, but once you start getting to 5, 6 or more variables, or if you're trying to put expressions in part of the paste call, it gets very cumbersome. And the other way to do this in base R is sprintf. There they have a specific format where you want to insert the values, and then you put all of the values you want to insert at the end of the call. So this is nicer because the string is easier to read than paste0, but the problem comes up when you have a lot of values that you're inserting, and maybe you flip the order of one or two of them, or you insert or remove a value, and then keeping track of where each of the values is actually being inserted is difficult, because there's nothing in the string part of the call that gives you a mapping between which value goes where. So glue is aimed to sort of solve these problems. So in this case, this is the same case, but the syntax is basically these curly braces and then the value that you want to insert at that location. So this gives you a direct one-to-one mapping of which position each value goes in. And as you can see here, this also allows you to put in an expression within those curly braces. So basically what happens under the hood is whatever code is within the curly braces is parsed and then evaluated. So there's also some convenience features in glue. So the first of which is that the string, the first parameter to glue is the string that you want to print. It's always trimmed to close to the shortest indentation, and this allows you to indent the string naturally in the rest of your code. If you were doing this without this feature, these lines would have to be all the way over to the left, and it would make your code harder to read. So that's a nice feature, but another thing that often happens is you have a really long string, and you want that string to be really long in the final output, but you don't want it to look like that in your code. So the way you get around that is if you use the double backslashes, that like it would work in a bash shell, that instead of creating a new line in that location, it just continues on the string. So you don't have to do things like g-subbing your string after the fact to fix this problem. So another thing glue gives you is some safety in terms of recycling. So in this case, there's 3 different types of recycling. The first case, you're recycling a 3-length value with a length of 1. And in that case, the 3-length value will have all of the values, but the single value will only be one value for each one. It'll be recycled. In the second case, both of the values have the same number of elements. In that case, each of them is stepped through like you would expect. So lots of things in R have this property. One thing that a lot of them don't have is if there's an inconsistent length. So if you have 3 of one value and only 2 of the other, that's inconsistent. It's not really clear. It's actually probably a bug in your code or in the data. So in that case, we actually throw an error or signal an error in that case. So you can actually only have these cases where either the values must be a single value and many values or the same number of values. So another case that often comes up in practice is how you handle missing data when you're trying to glue this data back into your string. So by default, glue does the same thing that paste 0 would do, which is convert missing data to an actual NA string. And this is useful in some cases, but often that's actually not what you want. So if there's also a parameter to the glue function that you can call, and if you call that with a null value, that tells glue that instead of inserting the NA, it propagates NAs. So these are actually an NA value rather than a string value. And this ensures that if there's an NA in your data that you're maybe not aware of, you get an NA value in return. So it allows you to catch these values up front, so you don't have issues later on in your pipeline. The last thing you can do is replace the NA values with some other value. And by default, this actually is set to the NA characters, but you can also set this to any other string value, such as in this case, I'm setting the NAs to no characters. So glue is designed to be really easy to use in packages. It has 0 non-based dependencies. It's tested all the way back to R 3.1. It's also designed to be customizable for package authors, so you can kind of tailor the behavior of the glue function to how you are using it in your package. And it also aims to be fast, so the speed of the code should not be the limiting factor on whether you include it in your package or not. So an example of this is creating an abort function, and this is useful for customizing error messages and providing more information for your users when there's an error. So in this example, it's doing like an HTTP request, and the content type that we got back from the request is different than what we were expecting. So we can create a simple template here and return both the expected content type and the actual content type as an error. And defining these types of helper functions I've found is really useful in packages because it allows you to, it lowers the burden on the package developer to providing this type of informative output, and that makes it very easy for you to include this type of output for your error messages. So I mentioned the customizability. So one thing you can do is change what the delimiters are. So, but by default they're the curly braces, but they can actually be any one or more length string. An example of that is, in this case, I'm using angled brackets to delimit the values I want to interpolate. And a use case for this would be using JSON data because it has so many curly braces in its format. You don't really want to use that as your glue delimiter as well. But if you change those delimiters to something else, then you can, something that's less common in the format, you can use that format instead, and without having to like escape everything. So another way you can customize your glue behavior is with transformers. So these are functions that allow you to change how the code inside of the braces is interpreted. In this case, I'm defining a shell transformer which shell quotes the values. So the transformers are given the code that's inside the braces and an environment to evaluate them in. And then you can parse the code like with the regular R parser and then evaluate it. And then with that value, we can then shell quote it by passing it to the sh quote function. And using this transformer, you can define a new glue function, glue.sh, and then use this, and it will automatically shell quote whatever's in the braces for you. So this is a good example to show that it really doesn't take a lot of code to write these transformers, but they can actually be very powerful. So another example transformer, this is a glue format. So this allows you to use like sprintf style formatting in your outputs. And basically how this is working is anything after the colon is the number of decimal, and the dot is the number of decimal places that you want to use for that value. So here I'm printing the 7 digits of pi, and then down here we're printing only 2 digits of this percentage. So you can also do more fun things. So this example is allowing you to insert emojis into your strings just like you would on Twitter or Slack or GitHub or whatever. So this is using the emo package under the hood. And this actually, it seems like it's a more complicated example, but this is the transformer to create this is maybe like 10 lines of code at the most. So it's actually a very, very small amount of work to do some more sophisticated things. And if you're interested more in the implementations of all of these, there is a transformer vignette that has all of the code. So I mentioned glue is fast. So what do I mean by that? So I think there's really at least 3 types of speed that people should keep in mind. There's the speed of how long it takes to sort of write the code in the first place. The speed of recall, so that's the ability of yourself or others to understand what your code is doing. And then also the speed of execution. And I think glue is really designed to increase the speed of both writing and recall. But also, I think people are very interested in the speed of execution, so let's see how it compares there. So glue is fairly fast on single strings. So glue is the orange here. And this benchmark is basically just doing the most simple thing you possibly can, taking a single value and inserting it into a string. And these 2 down here that are faster than glue are paste0 and sprintf, the functions defined in base R, and all of these other ones are other functions doing similar things to glue defined in packages. So that's interesting. If we now make this a larger set of strings, so now instead of returning a single string, we're returning 100,000 strings, we see this changes slightly. So glue is now mostly on par in speed with paste0 and sprintf. This is really taking advantage of vectorization inside glue. I should note that glue uses paste0 internally, so it's never going to be faster than paste0 just by logic. So why is glue fast? So all of the parsing to determine where the bracing functions are is done in a single pass in C code. So that takes very little time. The performance is really dominated by calling the parse function and evaluating the R code, and also paste0, which again, like I said, is used internally. And if your code still seems slower than you would expect, if you can reformulate your problem to take advantage of the vectorization of glue, that will speed things up quite a lot. And if there's more information, there's a vignette about sort of all of these benchmarks, and I would encourage you to check that out. So glue also contains more than just the glue function. So there's a glue data function. So this works the same way as glue does. So the glue function takes the data from your environment. Glue data allows you to explicitly set a list or environment as where the data should be coming from. And a use case here is you can use a data frame, pass it to glue data, and then the code is evaluated in the context of that data frame, which allows you to do things like access the columns of the data frame explicitly, rather than having to subset them. And you can also see the vectorization of all of the glue functions in this example as well. So glue collapse is just sort of a helper function that works the same way as paste with the collapse argument. Some features it has that using paste does not. It allows you to set a maximum width of your collapsed string, which is really useful in error messages, for instance. The other thing that this has is there's also a backtick function that will quote all of your arguments. That's sort of just a nicety. And this last argument allows you to have a different separator for the last two elements, which is useful for creating lists that read like you would see a list in English. So this function is really designed for use in creating nice error messages. So if you want to print out the values that were not found or whatnot, and you're not sure exactly how many values that's going to be, you can use this. If it ends up being like 100,000 values and would go way off the screen, you can restrict the width to the size of the console, and you won't have that issue. So another function that's really useful for generating SQL is called glueSQL, and what this does is handles all of the quoting for SQL strings. So this uses the connections for databases in the DBI package and the schema support in the DBI package to generate these strings. So then in this string, we give the table, so this table variable is actually a complicated, like an ID object from the DBI package, which encodes both the schema and the table that we want to retrieve. And then the values we can actually collapse into a list of values. And if we do this, we get a select statement that has the proper quoting for that database, including the schema and the table name, as well as proper quoting for the values in our list. So this gives you very nice, safe SQL statements. It's much better than trying to construct this by hand. It's very easy to cause SQL injection attacks if you're doing this type of thing without without worrying about how the quoting is being done. So the last sort of function I wanted to talk about is the str glue function. So this is actually a function in stringr that uses glue under the hood. And because stringr is one of the packages in the tidyverse package, and it's attached automatically when you load the tidyverse, this means that you have access to the str glue function as soon as you load the tidyverse. So you don't actually even have to worry about the glue package itself. You already have this package likely installed. So glue is popular, perhaps, so has about 60 reverse dependencies, so other packages that are using glue, such as Thomas's packages he mentioned today in the keynote. Glue has about 380,000 downloads per month. And I'm not claiming all of these downloads as glue. It's dplyr, stringr, and tidyr dependencies, so that's where a lot of these are coming from. But what that does give you is that there's at least some robustness to this package. It's being used in the real world by a lot of people all the time, and it's not running into problems. So it's, first of all, almost always, often likely already installed on your machine, and if not, it probably doesn't have any horrible bugs. So thanks everybody for your time. If you want to install glue, it's on CRAN, just install packages glue. The website is glue.tidyverse.org. That's me, and have an impressive day apparently. Thanks.
So we have time for one question.
Yes.
The error logging example was really neat. Can you go back to that? Because I'm wondering, that's a good example where you don't have control over what's coming in.
Yeah.
So are you
So like the one, this,
Because you had nicely indented.
where is that one?
It's pretty early.
Yeah. No, maybe it
You
was
should
earlier
repeat the
than this.
question.
Okay, yes, so the question was this, I'm trying to find this error logging example. It's the package one. Yeah, here, okay. So the question was this error logging example. Could be,
Multi-line and then it looks tolerant, right?
yeah.
The hope, of course, is
Yeah, so these expected, this actual content type could be whatever. It could be sort of, from the web server, it's basically could be any string. So are there any safeguards in this example to,
or the related question, could you invent an edit block to
yeah, so you can,
print
so
60 columns?
the short answer is there's nothing in this example to prevent the size, but you could definitely, and that's part of why I have the, like the glue collapse function has that ability to restrict the size of your output, is for this type of case, where you're not exactly sure what the data is going to be that you're pasting in, and you want to make sure it doesn't blow up the console of your user. So, good question.
All right, let's thank Jim again, and we'll get our computers started.